Hello to Dr. Shuko. So, this is our mini project. Our mini project system is a weather prediction and recommendation system. So, my group consists of 5 people: me, myself, Surya Arman, Prushwendra, Rishika, Rishi Arman, and Yogesh. So, I'll start with the introduction of the system. So we use clips to design an intelligent system by applying a knowledge base of facts and rules for predicting the weather and recommending the climates and temperature and the weather suits. So we use clips for weather prediction and analysis. So our system can identify specific weather conditions like hot and sunny or rainy day, while also offering practical suggestions like do you need to bring an umbrella or do you need to drink a water based on the climates. Okay, so next I'll pass to my Yogesh.
Okay, thank you, Mr. Surya. So I like to discuss about problem background for this project. So weather conditions significantly influence various aspects of human life. So these are the main challenges. So individuals still face challenges in making informed decisions due to the complexity and variability of weather patterns. So we use clip structure knowledge bases and logical rules to analyze meteorological data and generate weather predictions. So third one will be the expert systems make weather. So next will be the make weather prediction more accessible, accurate, and adaptable to specific. So the objective will be this system leverages a rule-based expert system to predict weather conditions by analyzing key meteorological parameters such as temperature, humidity, wind speed, and precipitation for various countries. So in this implementation, there are forecasts based on temperature, the ideal weather condition with some clouds, rainy day forecasts, and finally uncertain weather. And that's all from me.
Okay, for my part, I say about the data collections. First, we'll see about the countries. The collection of 10 countries is defined in the initial country's fact base. These countries serve as the primary location for which weather data and predictions are generated. After evaluating the weather observation, the system generates weather prediction for each country. These predictions are based on predefined rules and include the weather status. About the facts to be analyzed, the names of 10 countries are stored as the facts in the initial country's fact base. The initial weather fact base also stores individual weather observation for each country. Each observation includes temperature, humidity, wind speed, and precipitation data for specific country. Next, I pass to Madam Rishika.
So now I would like to present on methodology. So for methodology, we have used an online dataset to work on this. So as you can see for the top left image, it shows temperature trends over months, where the red curves represent average high temperature, where blue curves represent average low temperature. Where for the right panel, it shows a statistic summary, where the bottom left image shows the wind speed trends over time. The chart shows fluctuation in wind speed over the year, where the peaks in wind may correspond to storm warnings, where low wind speed values might contribute to predicting ideal weather.
So now I would like to talk about the tree graph. So basically, we initiate the facts of all the weather conditions based on the country, collect the attributes like the temperature and the wind speed, humidity, and the precipitation, and then we correspond it with each country to run the rules, which can then suggest the user to drink more water or carry an umbrella according to the rules. And then in the status attribute, we will collect all the countries' weather conditions based on the attributes.
Next, I'll present on results and discussion. Using clips produces accurate and useful forecasts by analyzing meteorological data such as temperature, humidity, wind speed, and precipitation for multiple countries. The accuracies of predictions depends on the rules in place, which are based on known meteorological patterns. In practice, more sophisticated models such as machine learning algorithms could be employed to improve prediction accuracy by learning from historical weather data and adjusting predictions dynamically.
Okay, so the conclusion of this project is to leverage a rule-based approach. The system accurately categorizes weather conditions based on key meteorological factors such as temperature, humidity, wind speed, and precipitation. Thank you.
Okay, so first we use def template for country, and then the attributes will be named. And then we use def template for weather also, and the attributes will be temperature, humidity, wind speed, precipitation, and countries. And we use multi-slot for countries. It's because it's more than one country. And then we also use def template for weather prediction. And then we use defects for initial weather to defect the facts, temperature, humidity, wind speed, precipitation, and countries with the values. So we also use defects for countries, which is USA, UK, France, Italy, Spain, South Korea, Argentina, Egypt, Saudi Arabia, and New Zealand. And then we use depth rule for predict hot weather. It will predict the weather, hot weather using the temperature. If the temperature is more than 30, and then we use if it's more than 30, it will, if the weather is hot, it will post the status as hot and sunny. And then we use depth rule for predict ideal weather. If the temperature is less than 25 and the humidity is less than 70 and the wind speed is less than 15, so it will show as ideal weather. And then we use depth rule to predict rainy weather also. So if it's rainy weather, it will predict as rainy day. And then partly cloudy weather. If it's partly cloudy weather, and then the status will be partly cloudy. And then if it's stormy weather, it will post status as stormy weather. And then if it's cold weather, the status will be cold weather. So after that, we'll use default to classify the climates, which is either tropical or dry. So if it's tropical, then the printout will be a tropical climate. And then if it's dry climate, if the humidity is less than 50 and the precipitation is less than 10, then it will be identified as dry climate. And then based on the climate, it will suggest and suggestions. So we use depth rule to suggest carrying an umbrella. And then we use another depth rule to suggest drinking water. So it will print out as stay hydrated and drink water. And then the summary will be, it will print out all the predictions and the suggestion for climates and the actions. So next I'll show you how to run the code. Okay, then now I'll show you how to run the code. Now we are entering the code for classification. So this will be the last printout. So now we're gonna reset and then as you can see, this will be the output where it predicted weather for the countries as rainy day, hot and sunny, and then it also suggested to carry an umbrella if it's a rainy day, and it also suggested for Saudi Arabia where it's hot and sunny to stay hydrated and drink water. And then it also identified the climate, which is tropical climate identified in Argentina because it's rainy day. And then it also identified in Italy where it has identified tropical climate also. So yeah, this will be the output and the run of our code. So that's all from us. Bye.